So in this video, I'm going to integrate three trig functions to kind of give you an idea of how you can integrate the other trig functions. The first one is tangent of x dx. First thing I'm going to do is I'm going to convert it to sine divided by cosine. So using that clever identity there, what I'm going to do is make a U-substitution. I'm going to let u equal to the cosine of x. And when I let u equal to the cosine of x, I can replace cosine x with u here. So this is 1 over u for the 1 over cosine x here. And then du, the derivative of cosine, is negative sine x dx. Well, guess what? I have a sine x dx. So how do I get that? Here, I need to divide both sides by a -1. So negative du equals the sine x dx. So I can replace this here with a negative du plugged in there. Okay, so that's what I'm going to do. I'm going to pull a negative out front to the front of the integral, and then the du, the differential there. So now I just need to integrate 1 over u du. Well, the negative comes out front. 1 over u du is ln absolute value u, and then plus c. But what is u equal to? U is the cosine, so I'm going to plug in cosine inside my ln here. And then I'm going to use log properties, where I have r ln x is equal to ln x raised to the r. So here's the deal, people. This is perfectly acceptable for the answer to the integral of tangent x. And your textbook uses this rule. Other textbooks use this rule. The only reason I'm going a little bit further is because the textbook I learned from actually uses a different rule, and I want to show you how that's derived. So they take this negative coefficient, pull it up here, becomes cosine to the -1. Now, if I have x to the -1, this is 1 over x to the +1, right? So I end up doing a reciprocal, and 1 over the cosine of x is the secant of x. So you can get this for the integral of tangent, or you can get positive ln of absolute value of secant x plus c. So I don't care which one you use, you just, make sure that you don't freak out if you're looking at an answer and they say that the answer is this one, but you got that one. You're thinking, how in the world did we get different things, when in reality they're the same exact thing there. So just wanted to show that for you so you'll know for yourself. Okay, so either one of these is an acceptable answer to me. Well, that didn't really work. Okay, whatever. All right, cotangent. So I'm going to do the same thing that I did for tangent. I'm going to convert it to cosine over sine. And I'm going to let u equal to the sine of x. And if u equals the sine of x, then I'm going to replace this and make it 1 over u. Okay. And du, the derivative of sine, is cosine x dx. That's the differential. So I'll replace cosine x dx with du. So integral of 1 over u du is ln absolute value of u, and u is equal to sine of x. So the integral is ln absolute value sine x plus c. Okay, so the integral of tangent is ln secant. The integral of cotangent is ln sine. Okay, the integral of secant, we actually have to be a little bit more clever here, and I don't expect you to know this. This is why I'm showing you the trick, and the trick is the same trick that you would use if you wanted to derive cosecant x dx. Okay, so it'll be the same trick here, just like these two had the same trick there. And so the trick is to multiply by clever 1. Remember, being a good mathematician, all you need to do is know how to multiply by a clever 1 and add a clever 0. So my clever 1 here is secant x plus tangent x divided by secant x plus tangent x. This is equal to 1, guys. So when I multiply by this, it doesn't change anything. Well, guess what? When I distribute secant gives me secant squared. And then the next is secant x plus tangent x. Why are these useful to us? Well, if I make a u substitution and I let u equal to the denominator, secant x dx, then I have 1 over u, okay? But what's the derivative of u? The differential derivative of secant x is secant x tangent x. And the derivative of tangent is secant squared. Okay, so that's the derivative here. And this is the derivative here. All right, sorry I wrote that in reverse order. I can see how that might be a little confusing, but I tried to do it in the order that I had it up here. All right, so this becomes 1 over u du because this right here multiplied by the differential dx, okay, is the same thing that's going on up there. So I would just replace that with du, and then I replace this with u. So I have to integrate 1 over u. And so whenever I integrate this, I'm going to get ln absolute value of u plus c, but u happens to be secant x plus tangent x. So the integral of secant x is ln secant x plus tangent x. Okay? So here's 3. This is half of the rules. So tangent is ln secant. Cotangent is ln sine. Secant is ln secant plus tangent. The other rules, cosecant is negative ln secant x, or I'm sorry, negative ln cosecant plus cotangent, which also you can rewrite this as ln absolute value secant x minus cotangent x plus c. That's another way to do that, where it's a plus in front of instead of a negative. Okay, and then another rule, I think I already said this, but this is also ln of secant x plus c. Okay, so it would be a good exercise for you to run through and see how these two are equivalent to each other, but they are the same answer. Okay, we ran through and did this one, and this one. You already knew that the integral of sine was negative cosine, and the integral of cosine is sine here. Okay, so now we're just putting all of the trig rules together.